In this tutorial, we will look at some common questions in the topic of acids and bases. Before we do that, let's do a quick review of the important parts of this chapter. For this chapter, firstly, we need to be very clear of the definitions of an acid, a base, and an alkali. And then after that, I would say a very important part of this chapter would be to know the reactions of acids and alkalis, meaning you need to know what can acids react with, what can alkalis react with, and in the reaction, what are the products that are formed. Next, we need to learn the definition of strength of acids and alkalis, followed by pH and indicators. And lastly, another important part of this chapter is the 4 different types of oxides. As mentioned, a very important part of this chapter is to know the reactions of acids and alkalis. So as shown in this question, the question is asking for the products formed when hydrochloric acid reacts with the different substances. So in our syllabus, we learned that acids can react with 3 things. Acids can react with metals, acids can react with carbonates and bases. So immediately we would be able to rule out D, because D is a metal salt which doesn't react with an acid. Next, we need to analyze the products of the reaction. When an acid reacts with a metal, we get salt and hydrogen only. So this looks correct. For B, when an acid reacts with a metal carbonate, we get salt, carbon dioxide gas, and water. So water is missing. And lastly, when an acid reacts with a base, we get salt and water only. So C is also wrong. Now we look at the reactions of acids and alkalis. There are 4 different reactions. The question is asking for in which reaction would a gas form. So let's analyze the reactions one by one. In the first column, we have an alkali reacting with an ammonium salt. So we have learned that when alkalis react with ammonium salts, we get a salt, ammonia gas, and water. So indeed, a gas will be formed in the first reaction. In the second reaction is of an alkali with a metal. So we have learned also in the syllabus that alkalis do not react with metals, so there will not be any reaction, there will not be any gas formed. In the third reaction, an acid with an ammonium salt, similarly there's no reaction. Acids don't react with ammonium salts, so there will not be any gas formed. So we have already established the answer to be B. But just let us take a look at the last reaction. The last reaction is between an acid and a reactive metal, which will produce salt and hydrogen gas. So indeed, a gas will be formed. In this question, we are looking at the reaction of an acid with a metal carbonate. Now, when an acid reacts with a solid carbonate, there is a particular phenomenon that may occur, especially when the salt produced is insoluble in water. For example, when sulfuric acid reacts with lead, we will get the salt lead 2 sulfate, and we have learned from our solubility rules that lead 2 sulfate is insoluble in water. So what happens when we have lead carbonate reacting with sulfuric acid is that the lead sulfate is going to form an insoluble layer on the surface of your solid carbonate, which will prevent your carbonate from coming into further contact or further reaction with the acid, and the reaction stops. Alright, so we say that the reaction stops prematurely. This happens when the salt that is produced from the reaction of the acid with the metal carbonate is insoluble. So for this question, the carbonate that will release the greatest volume of carbon dioxide is one where the reaction will go to completion. It's also the one where the salt produced is soluble in water. So let us check the four different carbonates used in this reaction. We have barium. So barium sulfate, barium carbonate will form the salt barium sulfate. Barium sulfate is insoluble in water. Calcium carbonate will form calcium sulfate, which is also insoluble in water. Lead, as we have seen, lead carbonate will form lead-2 sulfate, which is insoluble in water. So the only metal carbonate that will react with sulfuric acid to form a soluble salt is magnesium. So the reaction will go to completion, or rather magnesium carbonate will react completely and release the greatest volume of carbon dioxide. For this question is describing a very particular use of alkalis. In case you don't recognize the context of the question, I think some clues would be that we have calcium hydroxide, which is an alkali, and then we have ammonium nitrate, which is an ammonium salt. So the two compounds in this question should point you to the reaction of ammonium salts with alkalis. So over here is describing a particular scenario where a farmer adds ammonium nitrate and calcium hydroxide within a short period of time. So these two reactions will lead to a loss of nitrogen. So what happens is that the ammonium ions will react with your hydroxide ions to produce ammonia gas, and ammonia gas, being a gas, would escape from the soil, resulting in a loss of nitrogen in the soil. In this question, similarly, we are looking at the reaction of acids and alkalis. We have the same compound, ammonium carbonate, reacting with an acid and reacting with an alkali. So the question states that the gas evolved was tested with damp blue and red litmus paper, and we are asked to predict the color change. So the important thing about this question is to recognize what is the gas produced in each reaction. So in experiment 1, we have an acid reacting with ammonium carbonate. So if we look at the compound, it will be the carbonate that will be reacting with your acid, which produces your carbon dioxide gas. Okay, and we have learned that carbon dioxide gas is an acidic gas, so it's going to turn your damp blue litmus paper red, whereas your damp red litmus paper will remain red. Next, we look at experiment 2. In experiment 2, we are looking at ammonium carbonate reacting with sodium hydroxide. So we are looking at the reaction of an alkali with an ammonium salt, which will lead to the release of ammonia gas, and we have learned that ammonia gas is basic or alkaline. So it's going to turn your damp red litmus paper blue, while your blue litmus paper will remain blue. The next set of questions will be related to pH and indicators. For the part on pH, one concept that Cambridge likes to test on is this, that in very strongly acidic solutions or in solutions with very low pH, it simply means that the concentration of hydrogen ions is very much greater than the concentration of hydroxide ions. However, it doesn't mean that there is no hydroxide ions present. Okay, this is due to a reaction of water called autoionization of water. So no matter how strongly acidic a solution is, there will still be trace amounts of hydroxide ions present. Similarly, in very strongly alkaline solutions, there will still be trace amounts of hydrogen ions present. So for this question on the top, which ion is not present in dilute sulfuric acid, I think a common answer given by students would be B, but that is not the correct answer, and the correct answer would be your sulfide ion. Okay, because sulfuric acid will ionize in water to produce hydrogen ions, it will produce sulfate ions, and as mentioned, due to the auto-ionization of water, you will have hydroxide ions. So the ion that you will not get will be your sulfite ion. Next, for the bottom equation, you are told that you have a solution of hydrochloric acid with a pH of 2, and then what will be the pH of the acid when you add sodium chloride to it. Now the key question that you need to ask yourself is this, that will sodium chloride react with the acid? And then a subsequent question is sodium chloride itself acidic or alkaline or neutral? Now sodium chloride is a salt, it's actually a neutral salt. So when you add a neutral salt to an acidic solution, it's not going to change the pH of the solution. In this case, especially when the salt is a solid, so we are not changing the concentration of your solution, so your pH will remain constant at 2. The two questions on this page is related to the strength of acids, and before we even look at the question, I just want to point out that strength of acids and alkalis only depend on one thing, which is the extent or the degree of ionization and nothing else. Okay, so a strong acid would be one that ionizes fully in water. A weak acid will be one that ionizes partially in water. So over here, the question on top requires you to explain the difference between a strong and a weak acid, which is what we have already heard. Strong acid ionizes fully, and a weak acid ionizes partially. Now, a common wrong answer would be to make reference to the concentration of hydrogen ions. So students would say that a strong acid would have a higher concentration of hydrogen ions, whereas a weak acid will ionize in water to give a lower concentration of hydrogen ions. Now this is not correct, because the concentration of your acid can be adjusted by humans. Okay, so however, this description can be valid if the concentrations of your strong and weak acids are the same. Okay, if the concentrations of your strong and weak acids are the same, then the strong acid is going to give rise to a higher concentration of hydrogen ions compared to the weak acid. However, if there's no mention of the initial concentration, you cannot make the assumption that a strong acid will give a higher concentration of hydrogen ions, or another common one is that the pH of a strong acid will be lower than that of a weak acid. Again, that depends on the initial concentration of your acid. Next, in the MCQ question, which statement about weak acids is correct? So again, weak acids, there's only one definition of a weak acid, is that they are only partially ionized. This question is on pH and indicators. So over here, you are given two indicators. They are methyl orange and methyl red. Now, how do we interpret a table like this? Is that for when we are using methyl orange, for pH between 2 and 3, the solution or the indicator will appear red. For pH between 4 to 6, the indicator will appear yellow. So over here, this question requires you to determine the colors of 4 solutions in the presence of the two indicators, and in which solutions will both indicators be yellow. So we need to look for regions or pH in which both indicators will appear yellow, and that would be pH 6, and pH 6 corresponds to Z only. Okay, for Y at pH 5, your methyl red is going to appear red and not yellow. The last type of question that we're going to look at in acids and bases, even though this is a bit related to your chemical calculations as well, is that of a titration curve. So for a titration curve, it is a plot of pH against the volume of your titrant. So for example, when you're titrating acid against alkali, when we draw a plot of pH versus volume of titrant, then we get something that is called a titration curve, and the titration curve has this particular shape, which we call a sigmoidal shape or an S shape. Now for a titration curve, there are three important points to take note. The first point is the initial pH. The initial pH would tell us what kind of acid we have in the conical flask. So for example, the pH is very low at about 1, so we know that sulfuric acid is a strong acid. The second important point would be the pH when excess of your titrant has been added or excess of your sodium hydroxide is added. Again, the pH at this point would tell us the type of alkali that we have in the titrant. In this case, the pH is around 13, so that tells us that the sodium hydroxide is a strong alkali or a strong base. The last important point, which is the most important of the 3 points, would be this, that in a titration curve, there will always be a vertical region. Okay, in the middle of the vertical region, this is known as your end point or your equivalence point in a titration. Okay, when you perform a titration, this is also the point where the indicator changes color. So as mentioned already, this point corresponds to the point where the volume of alkali added has exactly neutralized the acid in the conical flask. Okay, so what is important about this point is the volume corresponding to your endpoint or the volume corresponding to your vertical region, and this volume is what we call our titer value in a titration. So given the titer value, given the concentration of your sodium hydroxide, we can actually calculate the concentration of the acid in the titration. So over here, the question requires you to explain in terms of the ions present why the pH in the beaker changes from 1 to 13. So you have to first mention that at the start we have sulfuric acid, so there's a high concentration of hydrogen ions leading to the pH being very low. As sodium hydroxide is added, neutralization occurs, so your hydrogen ions are reacted away, and therefore the concentration of hydrogen ions decreases and the pH increases. Okay, at the very end, after all the hydrogen ions have been reacted, the sodium hydroxide would be in excess. So when we add more and more sodium hydroxide, the concentration of hydroxide ions in solution will increase, leading to the pH increasing all the way to 13. The last type of questions that we're going to look at will be the types of oxides. This kind of questions are often routinely set in O-level papers. So you need to know very well the 4 types of oxides, examples of the 4 types of oxides and what kind of reactions they can undergo. So over here we have 3 oxides, X, Y, and Z. So the question tells you that X and Y reacts with dilute hydrochloric acid, but Z does not react. So immediately, or rather the conclusion, the deduction that we can make is that Z must be an acidic oxide. Okay, because it doesn't react with an acid. As for X and Y, we can only deduce that they are either basic or amphoteric oxides since they can react with dilute hydrochloric acid. In the next line, we learn that Y and Z reacts with sodium hydroxide, but X does not. So that immediately tells you that X is a basic oxide. So next, the fact that Y reacts with both an acid and an alkali, we can conclude that Y must be an amphoteric oxide. So with that, we will be able to conclude that D is the answer. For this question, you're required to know which types of oxides are acidic, basic, amphoteric, and neutral. So for aluminium oxide, we have learned that Z oxides are amphoteric. So it's either C or D. Potassium oxide is a metal oxide, so it's basic. Magnesium oxide, again, is a metal oxide, so it's basic. Sulfur dioxide is a non-metal oxide, so it is acidic.